Let's take this for example. We have caffeine, and caffeine has the following percentage composition. It's got 49.48% carbon. It's got 5.19% hydrogen. It has 16.48% oxygen, and it has 28.85% nitrogen. Its molecular weight is 194.19 grams per mole. This problem is asking not only for you to solve for the empirical formula, but now to also solve for the molecular formula. Let's go ahead and get started. I can go ahead and look at this and say, okay, I need to turn my carbon, my hydrogen, my oxygen, and my nitrogen into gram values. So right here it tells me I've got 49.48%. I'm going to assume that I have 100 grams of caffeine. Therefore, my 49.48% of carbon can turn into 49.48 grams of carbon. I can look at my hydrogen and do the same thing, 5.19 grams of hydrogen. I can look at my oxygen and I can say, all right, I've got 16.48 grams of oxygen. And I can look at my nitrogen and I can say, all right, I've got 28.85 grams of nitrogen. Now I can multiply these all by my conversion factors found by my periodic table. Multiply this, that 1 mole of carbon is equivalent to 12.01 grams of carbon. I can multiply this and say that 1 mole of hydrogen is equivalent to 1.01 grams of hydrogen. And I'm getting this all off the periodic table. These are all the atomic masses. And I can look and I can say 1 mole of oxygen is equivalent to 16.00 grams of oxygen. And I can look again and I can say nitrogen, 1 mole of that is equivalent to 14.01 grams of nitrogen. So there we go. These are all the equations that I need to solve for moles. So when I do this, and this, and this, and this is what I end up with. 49.48, that's going to be equivalent to roughly 4 moles. 4.12 moles. I can go ahead and I can do this problem here, and this is going to be equivalent to roughly 5.14 moles. I can continue down and do 16, and this is going to be roughly equivalent to 1.03 moles. And I can go again, and this is going to be roughly 2.06 moles. So as you remember, we're still trying to find the empirical formula, and it's going to be easiest to find the empirical formula first. So I divide all these values by the moles that are the fewest. So look, we found out 1.03 moles is the smallest. So we're going to divide all these by 1.03 moles, 1.03 moles, 1.03 moles, 1.03 moles. Now, what I'm going to find out is my subscript for my empirical formulas for each element found. So I take 4.12, I divide it by 1.03, and of course I get 4 for my carbon. And I can take 5.14 and divide it by 1.03, and I get roughly 5 for hydrogen. And I go ahead and do 1.03 divided by 1.03, and I find out that I get 1 for oxygen. And I go ahead and do the same thing, 2.06 divided by 1.03, and I find out that I get 2 for nitrogen. So when I take all this into account, my empirical formula ends up being C4, H5, O, and 2. Now if that's what you got for your empirical formula, you can go ahead and give yourself a pat on the back for show. Nice job. So now I'm going to clear this and we're going to continue, because remember, the problem asks not only for the empirical formula but for the molecular formula as well. So I'll clear this and I'm going to rewrite our empirical formula up here. My empirical formula again was C4H5O N2. Now, after you find your empirical formula, it's actually quite simple to find the molecular formula, and we're going to need to use this piece of information here, the molecular weight of caffeine. But the first thing I need to do is I need to calculate the molecular weight of my empirical formula. So what I do is I just count my atoms, just like you guys have done in class. 4 carbons, each worth 12.01, and that equals 48.04. And then I look at my hydrogens, I see I got 5 hydrogens, and I multiply that by 1.01. Again, these are the atomic masses I'm getting off the periodic table. You guys have done this before. 5.05. And I take my oxygen, I've got 1 oxygen atom, I multiply that by 16, which is the atomic mass found on the periodic table, and that is 16.00. And I go ahead and I do nitrogen, 2 nitrogen atoms in that molecule, and I multiply that by the atomic mass, 14.01, and I get 28.02. Now I add all these bad boys up together, and what do I get? I get a result of 97.11 as my atomic mass for my empirical formula. Now, the only thing I need to do now is I need to take the molecular weight of my total molecule, 194.19 grams per mole, and I needed to divide it by the empirical molecular mass, 97.11 grams per mole. And what I get from that is actually 1.99. And when we round that, we could say that's 2. So what that means is that this is now a multiplier. Which means I'm going to multiply my atomic, or my empirical formula, C4H5O N2. I'm going to multiply all this by 2. So 2 times 4, now I've got 8 carbons. 2 times 5, now I've got 10 hydrogens. 2 times 1, now I've got 2 oxygens. And 2 times 2, that is 4 nitrogens. And so this here would be my molecular formula for caffeine. It's a multi-step problem. There's a lot to think about. So let's go ahead and practice a little bit more. Before you move on and try one by yourself, these are the steps for success. Remember, you need to assume that you have 100 grams of the given substance so that you can turn those percentages into gram values. Then you need to convert each mass into moles. We use the atomic mass found on the periodic table. Our new unit's grams per mole. It allows us to make a conversion factor. If you need a little refresher on how to do that, go ahead and rewind the video and watch it again. Then you need to divide each mole value that you calculated by the mole value that is the least. That's going to give you your coefficients for your empirical formula. When you round all these, then you get those perfectly round numbers, and you can set those as subscripts in your empirical formula. Then you need to find the molecular mass of your empirical formula and use that, divide the molecular mass by the empirical formula, and you find the multiple required to find the molecular formula. Now I know in list form this probably doesn't help you too much. Maybe a couple of these steps you'll be able to remember, but at least you can go back, try to refresh your memory, go back to the other examples that I just did for you and try to refresh your memory, and then you can move on and go ahead and try this problem here. What are the empirical and molecular formulas for a compound with 86.88% carbon and 13.12% hydrogen with a molecular weight of about 345 grams per mole? Go ahead and pause it, and then I'm not going to show you how to do this one, but I'm going to give you the answer and see if you can check your work. Now when you guys go ahead and do this work, you'll find that the empirical formula is going to be CH2. That's your empirical formula. Now when I do the division of the total molecular weight divided by the empirical molecular weight, we end up with a molecular formula that's equivalent to C25H50. It's a lot of carbons, that's a lot of hydrogens. So go ahead and check your work. I do hope that this video has been helpful. If you have any questions, you can ask me, you can ask DeMaria, you can ask Werner, and we'll get you on the right track. This is Underwood, signing out. Sayonara.